In this clip, we're going to review all the knowledge that you need on area, perimeter and volume in order to take you through foundation and intermediate tier GCSE from probably grade E type questions up to grade B. So the basic things that you need to take from your learning through Key Stage 3 and probably Year 10 with regard to area and perimeter, you are expected to know how to find area and perimeter of the following standard shapes: so rectangles, triangles, trapezia and circles, as well as shapes that are made up of these, and these are called composite shapes. When we're talking about perimeter, we're talking about a length, so the total length around the boundary of a shape. Its units, its metric units would typically be millimeters, centimeters, meters, kilometers and so on. So perimeter measures length, distance. Area measures how much surface is covered by a two-dimensional shape. And its units are typically squares, so millimeters squared, centimeters squared, meters squared, square kilometers and so on. So for the basic shapes, for a rectangle, you've usually got a length and you've usually got a width. So to work out its area, it's length times width. It's one of the first things you would have discovered about area. Then we come to a triangle. Again, this would be Key Stage 3 work, and what you would have learnt is that if you know the length of its base and its perpendicular height, and that's important. Perpendicular height is the height that's at right angles to the base. Now it doesn't have to be in that orientation, it could be spun around there, but what you're looking for is a perpendicular or two measurements that are at right angles to each other. So the area of that is a half of the base times the height. In effect, what you're doing is imagining that was a rectangle, so you'd work out the base times the height and then halve it, because the area of the triangle is half what the rectangle that it would fit within would be. So you're not given those, you are required to remember them and use them. When we come to composite shapes, what we have to do is to break the shape up into shapes that we can work out the area. So you can see with this composite shape there, we have a rectangle there. So if we call that the area of rectangle A and work that out, and then this rectangle here, so long as we knew a length and a width, we could work that out. So its area would be the area of A plus the area of B. With a shape like this, again, depending on the measurements that you're given, you could do it the same way as we've done there. So we could split that into one rectangle there, one rectangle there, one rectangle there, and work out each of those separately and add them together. But often a quicker way to do that would be to work out the area of the whole rectangle. So if you imagine that you've got a whole rectangle there, so you'd work out area of whole rectangle, and then if we worked out the area of that gap there and we subtracted them, so we work out the area of the complete rectangle and then subtract from it the area of that small rectangle. And for this one, you'd work out the area of triangle A, and you'd work out the area of triangle B, of rectangle B, and you'd add those together. So area of triangle A plus area of B. Now at GCSE, certainly foundation tier, that is the level of challenge that you would be expected to work with. So let's take a look at some examples of increasing complexity here. So this first one is just a straightforward rectangle. So the area would be 7 times 8, which is 56. The units are centimetres, its area, so the units would be centimetres squared. And often with an area question or a volume question on a GCSE paper, you will be asked to state the units of your answer, which means if you don't, you will lose 1 mark. So look out when you're working with area or volume to see if the question is saying and state clearly the units of your answer. Okay, so the next one is a triangle. I've got my perpendicular height to the base, so the area is a half times 10 times 12. So 10 12s are 120, half of 120 is 60, and again the units would be centimetres squared. Now we're into composite shapes. So here I've got a rectangle, or 2 rectangles connected. So if I call that one A and that one B, I can see here that the height of A is 8, but there's nothing telling me exactly what the width of that is. But I do have this additional information here that the distance from there to there is 15, and the distance from there to there is 6. So this distance is going to be 15 less 6, which is 9. So the area of A will be 9 times 8, 72. And similarly for the area of B, I've got this width, but I don't have the height or the length of it, or I've got the length and the width, however you want to think of it, but I do know that from there to there is 8, and from there to there is 3, so that distance is going to be 8 less 3. So that's 5. So the area of B will be 6 times 5 equals 30. So the total area will be the sum of those. So 102 centimetres squared. For this one, well, I've got the triangle, which I'll call A, and the rectangle. So the rectangle is easy, it's 3 times 4. For the triangle, I know the height is 4. I need to know this distance, and this distance is going to be 7 less 3. So the area of the triangle, the area of triangle A will be a half times 4 times 4. 4 4s is 16, half of 16 is 8. The area of B is 3 times 4 equals 12. So the total area, I'm going to add the 2 together, will be 20 centimetres squared. And then for this shape, I'll do it by subtraction. I can see the total rectangle will be 12 times 6. This will be 7 times 4. So the area will be 7 times 6. Take away 7 times 4. 7 6s are 42. Take away 7 4s, which are 28. I can't take 8 from 2, so I have to write it as 3012 rather than 42. That leaves 4 and that leaves 1, so the area of the shaded region is 14 centimetres squared. So that's taking us through really the grade E type questions, where we're working with just basic rectangle and triangle shapes, and composite combinations of those shapes. Another shape that you're expected to be able to find the area of is a trapezium. Now, a trapezium is a quadrilateral, which means it's a four-sided shape, and it has one pair of parallel sides. So you can see here A and B are parallel to each other. They're vertical, but they're still parallel. And we need to know the parallel sides and the perpendicular distance between them. Some of these look a bit wonky, but they should be perpendicular distance. This formula is given to you on the exam paper. It's the only formula you're given in the intermediate and foundation tier, and it tells you this. So it's written like that: half times A plus B in brackets, which means you work it out first, times H. So A plus B are the parallel sides. So it's the sum of the parallel sides times the height halved. So half the sum of the parallel sides times the height. So let's have a look at how we work that out. So with this one, the area will be, if we just write it down as we see it, so a half, need to put times in there, half times A plus B parallel times the height 4. Now you could be asked this on a calculator paper or a non-calculator paper, so let's work it out without a calculator first of all. So I've got a half, 6 plus 8 is 14 times 4. Half of 14 is 7. 7 times 4 is 28. Or you could do half of 4 is 2. 2 times 14 is 28. Or you could work out what 14 times 4 was and half that. It doesn't matter which order you do it. You're going to end up with 28. If you were able to use your calculator for that, you can type it on your calculator exactly as we've written it there. So you'd start off with a fraction, half times open bracket 6 plus 8 close bracket times 4. So as I try to encourage you, write it down as a line of maths and then put it into your calculator in exactly the same way, and you get 28. For this one, the orientation has changed, but it's still, there's my parallels, there's my distance between them. So the area, half the sum of the parallel sides times the distance between them. 12 add 6 is 18 times 5. Okay, it's a bit more work on the calculator, but you've got half of 18 is 9. 9 fives, 45, and the units square centimeters. On the calculator, fraction, half times open bracket 12 plus 6 times 5, and that's coming up 45. I'm not sure why, can't see that very clearly this morning. 45. So that's your trapezium. Next we come to the circle. Two formulas you need to know here, but a little word about pi first of all. So pi is a universal constant, doesn't change, and it's an irrational number because you can't write it as a fraction. You can't write it as 3 over 4 or something like that. And it's the value that you get when you divide the exact perimeter of a circle by its exact diameter. And these are the language of circle that you need to know as well. Diameter is the distance across the widest part of the circle, so it goes through the center. The radius is half that distance, which is the distance from the center to the outside. In circle terms, we don't talk about perimeter, we talk about circumference, but it, to all intents and purposes, means the same thing. And you need to know and recall these two formulae. Area is pi times the square of the radius, so pi times r squared, and the circumference is pi times twice the radius, which is the diameter. As far as trying to remember it, if you write it like this, so you know you're always going to have a pi, an r and a 2, all you then need to remember is one of them you're doubling, one of them you're squaring. Area is going to be a bigger number generally than the circumference, so squaring gives you a bigger number than doubling. So for example, if we had a radius of 3, 3 squared is 9, 2 times 3 is 6. So the area is the squared version. So pi r 2, pi r squared, pi 2r, pi times twice the radius of the circumference. If you are on a calculator, paper 2, a calculator allowed paper, then you can find the pi button. It's above this times 10 to the power of. So you would do shift and that button to get pi. If it's a paper 1, a non-calculator paper, then unless you're told otherwise, you use pi to be 3.14. So the first example, a circle has a radius of 4.3 centimeters. Find its area and its circumference. So it's a radius of 4.3, so r equals 4.3. So its area is pi times r squared, 4.3 squared. And on our calculator, we can work that out. So shift, there's my pi, times 4.3, that's the squared button there. So calculate the screen exactly the same as what I've written. That'll give it as a multiple of pi. To turn it into a decimal, we do SD. So that would be 58. And if I wanted to give it to one decimal place, that's one decimal place. So it's either 58.0 or 58.1. The next digit is 5 or more, so it's 58.1. And the units would be centimeters squared. The perimeter, the circumference, would be pi times 2 lots of 4.3. So pi times 2 times 4.3, written and typed exactly the same, and that would be 27.0 to one decimal place. And the units of circumference, its length, its perimeter, so that would be centimeters. A wheel has a diameter of 60 centimeters. So this time now it's the diameter we're working with. How many times will it turn as it travels 1 kilometer? So we've got a context here, a numeracy style question where we're working with a wheel. Now if we know its diameter, we can work out its circumference. Now the circumference of a wheel or a circle would tell you how far it would go in one complete turn. If you imagined that I took that circle there and cut it and then laid it out flat, the flat distance would also be its circumference. So cutting that and rolling it out flat, that would be its circumference. So that's how far it would travel in one complete turn. So if I was to cut it and lay it out flat, that would be the circumference, how far it travels in one complete turn. So if I want to know how many times it will turn as it travels 1 kilometer, I would want to work out its circumference and then divide that into a kilometer. But what we need to be careful of here is that we need to be working all in the same units. So if I turn that into meters and that into meters, because those are two equivalences that I need to know, 100 centimeters in a meter and 1,000 meters in a kilometer. So diameter equals 0.6 meters. The distance equals 1,000 meters. So now I'll be working in consistent units. The radius will be half of that. Now we can work out the circumference. Pi times 2 times 0.3, which gives you back to the diameter. You could remember circumference as pi times diameter, but I think it's easier if you're just working, if you're trying to remember both of those and you're not very good at memorizing, to keep them both in terms of pi, 2 and r. So pi times 2 times 0.3, pi times 2 times 0.3 equals 1.88 meters. So the number of turns will be 1,000 meters. How many times will 1.88 go into that? I'll keep that whole value on my calculator, even though I've rounded it there. So I'm going to do 1,000 divided by my previous answer, which I get by pressing that ans button. So 530.5. So if we're talking about complete turns, there'd be 530. In 1 kilometre. So the number of turns is 1,000 divided by 1.88. That works out to be 530.5. So how many complete turns? There would have been 530 complete turns. So that's the circle. Then we come to volume. So volume is a measure of space occupied by three-dimensional objects. The units of volume are cm3, centimeters cubed, meters cubed. But if we're talking about liquid, then that tends to be called capacity, which is another word for volume. And the units then tend to be milliliters and liters. And this equivalence here, you need to know. That's often asked of you, that 1 litre is equivalent to 1,000 cubic centimeters. This is another piece of information you're provided with on the GCSE exam paper, which is to do with volumes of prisms. The volume of a prism is the area of its cross section times its length. Now a prism is a three-dimensional shape that keeps its cross section whenever you cut it. So that's the shape you're given, and what that means is no matter how many times I slice through that with a knife, the length changes, but the area that you're cutting through remains the same. So this is a prism. If that's my area of cross section, then if I slice it vertically, the length will change, but the cross-sectional area remains constant. And a cylinder is another example. If you imagine that's a sort of Swiss roll or something, no matter how many times you slice it, the face, the circular face, has exactly the same area. So with that shape, what we tend to write is a length, a width, and a height. It doesn't have to be those letters, but the volume of it will be length times width times height, and its units would be, if that was centimeters, centimeters cubed, meters, meters cubed, and so on. For a cylinder, you were usually given the radius or diameter of the circular face and the length or the height, depending on its orientation of the cylinder. So the volume of that will be the area of cross section, the area of the circle, which is pi times r squared, which we met on the previous sheet, times that vertical or horizontal length, distance, height, whatever it is. I've written L there and H there, which is a bit stupid. So pi r squared times length, or if it was that way round, you'd be talking about pi r squared times height. It doesn't matter. So if we take a look at a couple of examples. So we've got a volume, calculate the volume of the following. So here it's a pentagonal prism, so its cross section is the shape of a pentagon, and we're not asked to work that out because they're telling us what the area is, and they're telling us that the length is 1.5 meters. So whenever you're working with areas, volumes, perimeters, just like we looked at that wheel question, we have to have everything in the same units. So because the area is in centimeters squared, we will turn that length into centimeters. There's 100 centimeters in a meter, so 1.5 will be 150 centimeters. So the volume will be the area of the cross section, which is 50, times the length, which is 150. And if we work that out, we get 50 times 150, which is 7,500 cubic centimeters. If for whatever reason we would want to turn that into a liquid, so let's say that that was a pentagonal box or something that we wanted to pour fluid into, then we'd have 1,000 centimeters cubed is 1 litre, so you divide that by 1,000, so its capacity would be 7.5 litres. So didn't ask for that, but it's worth me using that as an example. So to turn a volume into a capacity, you're changing from centimeters cubed into litres by dividing by 1,000. Triangular prism, this time we need to work out the area of the cross section. So the area of the cross section, triangle, we met that earlier, half base times height, 10 times its perpendicular height. You need to be careful. Sometimes what an exam question will do will give you a third measurement for that triangle, and then you have to make sure you are using the correct pair, the perpendicular pair, to get that. So 10 tens are 100, half of that is 50. So the volume is the area of the cross section times the length. Area of cross section times the length. So 1,250 centimeters cubed. So if we wanted to work out its capacity, we would divide by 1,000. So 1.25 litres. Question 3. A cylindrical drum has a diameter of 60 centimeters and a height of 1.4 meters. Find the capacity of the drum in liters. So if we do ourselves a little sketch. So there's my cylindrical drum. Its diameter is 60 centimeters. Its height is 1.4 meters. So I need the area of the cross section, pi times 2 times r, and I need its height, and because I want it in litres, I need to be working in centimetres. So I'm not going to change that into metres, I'm going to change that into centimetres. I need the volume in centimetres cubed in order to change it into litres. So the height will be 1.4 times 100 which is 140 centimeters. So the volume equals the area of the cross section, pi times r squared, so 30 squared. Diameter equals 60 centimeters, so radius equals 30 centimeters. Radius is half that. So the volume is the area, which is pi times 30 squared, times the height, which we're going to use in centimeters. So pi times 30 squared times 140. So again, type in the calculator exactly as is written, change it to a decimal, and we have 39580.6744. Capacity, that's centimeters cubed, will be that divided by 1000. So 395.8 litres. So if we were to round that to, let's put it into significant figures, let's say to one significant figure. One significant figure would be the 3, so it's either going to be 300, 300, or 400. It's closest to 400 to 1 sig fig. Question didn't ask you to give it to that accuracy, but that's what it would be. If it was to two significant figures, it would either be 390 or 400, and the 5 would make it closer to 400. So two significant figures, it would be the same. To three significant figures, it would be 395 or 396. That would be closer to 396. So those are what you'd say would be fairly standard volume and capacity questions, grade D. Where they make things a little bit more challenging is where they give you an area or a volume or a capacity and expect you to work backwards in order to find one of the original dimensions, the length, the width, the height of the shape. So this first question, a rectangle is an area of 45 square centimeters. If one of the sides is 9 centimeters, find the length of the other side. Often a little diagram helps you with questions like this. If you're not given a diagram, it'll help you visualize it. So what we have here is, we know one of the sides is 9. We don't know the other side. So if I call that L, and I know that the area of the shape is 45. So for a rectangle, area equals length times width. So the area is L times 9, and I know that that is 45. So I'm thinking, what have I got to multiply 9 by in order to make 45? From an algebra point of view, if you want to get the L on its own, we have to undo the times by 9, and we do that by doing the opposite of times by 9, which is dividing by 9. So the length would be 45 divided by 9, which is 5 centimeters. And if you check your answer, that's 5, that's 9, 9 5's 45, job done. A rectangle has a perimeter of 140, back still on a rectangle. The length of its shorter side is 25. Find the dimensions of the rectangle and its area. So I know that the total distance around that is 140. If I take off the two sides I know, that will leave me with the two lengths that I don't know, that have to be the same. So 140 less 25 less 25 is 90. So those two have to add up to 90. So if I do 90 divided by 2, is 45. And then you can check. So 45 plus 45 is 90, plus 50 is 140. A square has an area of 64 square centimeters. So the area of a square is length times length. So you're looking for a number that you're multiplying by itself, because it's a square, it's the same length as width, that makes 64. So you're either going to do that by going through your square numbers in your head, or L times L is L squared, which is 64. Depends how much algebra revision you've done. In order to undo a square, you square root. So you're looking for the square root of 64, and the square root of 64, again, you should know your square numbers up to 100, but if you needed to use your calculator, 8. So 8 times 8 is 64. So if it's a square you're talking about, then they're expecting you to be able to deal with opposites of square rings, which are square roots. And finally, a fish tank in the shape of a cuboid contains 400 litres of water. If the base of the tank measures 1 metre by 80 centimetres, how deep will the water be? So let's just get our fish tank going here. So that's a cuboid. It contains 400 litres of water. If the tank measures 1 metre by 80 centimetres, so it's 80 that way, it's 1 metre this way, I need to be in centimetres because I'm dealing with litres. So that's going to be 100 metres. And I know the depth of the water. No, sorry, I want to find the depth of the water. Like that. So volume is length times width times height. And the volume is 400 litres. To turn that into cubic centimetres, I know 1 litre is 1,000. So 400 times 1,000 equals 4 followed by 1, 2, 3, 4, 5 zeros. So I've got 400 cubic centimetre volume. So now I know that 400,000 is the length, which is 100, times the width, which is 80, times the depth, which I don't know. I can work out what 100 times 80 is. 1, 2, 3, 4, 5 is 8,000 times the depth. So to get the depth on its own, I have to do the opposite of times it by 8,000, which is dividing by 8,000. So the depth is 4 followed by 5 zeros divided by 8,000. So don't need to use a calculator. 5 zeros, 3 zeros, 50 centimeters. So the depth there is 50 centimeters. And that, now we're talking about a very typical numeracy type question where you're working with either a cuboid shaped tank or a cylindrical tank, and they're giving you the capacity of the water in it, and you need to work out the depth of the water. So that's the sort of thing you need to be practicing. Okay, so that's taken us through area, perimeter and volume up to sort of grade C, B level of difficulty.